Water is the most important resource in a permaculture design. We can take a home from losing all the surface water straight into the street to becoming abundant with a complex set of pathways for the water. Here is an old pool at a school in the middle of Australia on the dusty Nullarbor Plains. Bill Mollison said water would become a commodity. He was saying that in the 80s. Looking back on it now, it seemed obvious, but at the time it was very controversial. So there are a lot of decisions we need to make when we're making our design. We work out what are our potable or potable water needs. What's the storage capacity? How much do we need to store? What types of storage can we use? How will we catch the water? You will be catching rainwater and condensation. And how can we make the distribution of the water complex so it's used many times? When we go to reuse the water, we want to make sure it's been filtered and pollution-free. So the design aims to catch and store potable water and catch and store water and put it into the ground. We're going to use complex, slow distribution methods so that we reduce erosion. And we will also use the water to serve wildlife, especially fish and eels. Let me show you a little bit about the hydrological cycle. What goes up must come down, and what comes down must go back up. If we want rain, then water must go back up to make clouds. A lot of rain is created over the ocean. The sun causes the surface of the water to warm up and evaporate, like steam. The water rises and the atoms cling together in the clouds. What I didn't know when I started my learning journey was that the clouds were seeded by particles, and these particles cause it to rain. Like when we get dust in our eyes, causing us to cry. The particles usually come from the forests, but sometimes from industrial smoke. And often when they come from industrial pollution, they make acid rain. Whereas when they come from the forests, they are rich in nutrients. The droplets support life on land and in the ocean. To make a good design, you need to understand water. Ask questions like, what is water actually made of? How do those molecules, or those atoms, bind together to make a molecule? Where is the water that we want to catch? How does that move around? What will be the impact? What are the benefits of keeping water on site? And what are the threats? And finally, how are we going to use the water? The water molecule is a central oxygen atom with holding on to two hydrogen atoms. There's an electric bond between the oxygen and the hydrogen. That bond gets broken pretty easily when it heats up, but when it's together as a water molecule, it also has a slightly negative charge, and that influences its behavior. That molecule of oxygen holding on to two hydrogen breaks easily when it's turned into a gas. Water molecules also love to stick together. Sometimes a water molecule will travel against gravity, defying gravity, to cling to another water molecule. We can see this if you look at the meniscus, the top of the water in a glass. You'll see it rises slightly at the sides. And we can also see this when we look at those odd formations of sideways formations of stalactites in the limestone caves. If an area is already wet, then the water that's coming there will prefer to go where the wet patches are, unless it's in a hurry. It is good to understand how water moves in the air. So the global annual rainfall averages out to 800 millimeters, and 480 millimeters of that evaporates back into the atmosphere, whereas the rest of it travels out into the ocean. We also have mist. Somewhere between 40 and 94% of the precipitation, the water that's in the air, is mostly mist. And forests catch a lot of condensation as well as rain. There's more condensation than rain. Rainwater is different than pure water molecules. Rainwater, as it falls from the sky, contains a lot of nutrients. Water has an amazing ability to dissolve many things. In fact, it's called a universal solvent because it will dissolve most ionic bonds in the universe. And the way it dissolves is threefold. It can do it chemically, mechanically, and slightly electrically, because remember, it's slightly negative. There's different ways that water can go into soil. We talk about infiltration as an ability of the water. It's more an ability of the soil to allow it to infiltrate. And then if it doesn't infiltrate, you'll get surface tension. And where it's pooling slightly, you might get capillary action. Dissolving happens. But if none of that happens and there's pools of water on the surface, you're going to get evaporation. Evapotranspiration occurs when the water leaves the trees. It transpires through the leaves in a similar way that we perspire. But unlike the human body, water in a tree is not circulated. In the human body, we have a blood system that circulates water. But in the tree, it's constantly being transpired. The tree also catches rain and directs it down the trunk and down into the root zone. But again, it has to pump the water back up through transpiration. You can notice the effect of transpiration, evapotranspiration, when you sit under a tree on a sunny day. It's cooler under a tree than under a roof because the tree pumps water all day, and especially on hot days. We know when water moves, it cools down, it loses energy. You'll notice this effect best in a dry forest. There are quite a few transpiration technologies. These days, we have water exchangers and air cooling systems, especially in dry climates. Another ingenious technology is wicking. As water evaporates from the leaves, it creates a miniature vacuum. This vacuum begins the process of sucking water up through the tree's capillaries. So the leaves do capillary pumping, the trunk is a water conductor, and with capillary action, the roots perform desalination. One of my favorite technologies is wicking. I use wicking pots and I use it in the ground, and it's helped our food forest survive droughts and periods when we've been away on holidays. The two biggest design mistakes that we can make when creating a water plan is decoupling and hoarding. Decoupling occurs when you remove any risk of water coming on the site from outside the site, except for rainwater. Some people have put in drains along the back of their site. They've deepened the water courses because of the great fear of water inundation. But in fact, decoupling a site is worse than deforestation, because decoupling in periods of very low rainfall, such as a drought, kills the soil. When we tamper with a waterway, we're destroying the habitat of any of the creatures that depend upon it. Another thing to be mindful of, there are laws against hoarding water. So this is a good reason to keep only 10 to 15% of your rainfall as potable water and store the rest of it in the ground. In summary, for part 1, water is life and decoupling it is destructive. Capture the condensation as well as the rainwater. Rainwater contains nutrients, not just hydrogen and oxygen. Water dissolves many things, and this helps nutrient transfer, but it also aids erosion. Plants transpire water, and they seed the clouds. Evapotranspiration cools trees and the area around them. Transpiration technologies include cooling and wicking. Part 2 of this video introduces you to design ideas for potable water versus in-ground storage. We look at how to harvest as much water as possible, how to stop the losses, how to spread the water out, why we should aim to store only as much potable water as we need, how to clean the water, then share it.